Hello, welcome to a video on matrices. Today we're going to be looking at when is it possible and when is it not possible to multiply two matrices together, because as you've already seen from another video, I'm sure, it's a bit more complicated than just multiplying two numbers together, because for a start it even matters what way round the two matrices are, but sometimes it's not even possible to multiply two given matrices together. So that's what we're dealing with today. So to get us kicked off and started, a really important thing when looking at multiplying two matrices together is the dimensions of those two matrices. So what do we mean by dimensions? Well, in the previous video you were looking at matrices of this sort of style, let's say. Matrices that look like this. Now these matrices are called 2 by 2 matrices, and they're called that because they've got two rows and two columns. So if we're talking about a matrix in general, an m by n dimension matrix, the first number is referring to the number of rows in the matrix, and then the second number is referring to the number of columns in that matrix. So for instance, if we were actually looking at a 3 by 2 matrix, that could look something like this, for instance, because it's got 3 rows and 2 columns. Okay, now that's going to be really important once we know what the dimensions of a matrix are, because this is the thing that decides is it possible or not to multiply two matrices together. And the reason for that is if when we're multiplying two matrices together, then what we're doing is we are multiplying the rows in the first matrix by the columns in the second matrix. And the only way therefore that would work is if the rows, the length of the rows in the first matrix, are the same length as the columns in the second matrix, i.e. they match up and each number has another number to multiply by. But the length of the rows in the first column is the length of the rows in the first matrix is the same as asking how many columns are there in the first matrix. And we know from how we're writing the dimensions of a matrix, we now know that the number of columns is decided by this number here. And equally, the length of the columns in the second matrix is the same as saying how many rows are there, and the number of rows is decided by the first number written in the dimension of the matrix. So therefore, if you're trying to see if it's possible to multiply two given matrices together, what you're kind of doing is you've got to look at the dimensions of the two matrices and see if these two numbers here and here are the same as each other. Kind of like the middle two numbers, I guess you could say, because you've got a total of 4 numbers written here. You're looking at the two middle numbers of those 4 numbers to decide if they're the same. Yes, it's possible to multiply the matrices together. If they're not the same, nah, you can't do it. So let's look at another example. Let's say we have a 3 by 2 matrix multiplied by a 3 by 3 matrix. So that means, as I said, we've got a 3 by 2 matrix over here, and we've got over here a 3 by 3 matrix. Is it possible to multiply them together? Short answer, no. It's that simple, just because this number and this number are not the same as each other, so it's not possible. However, if we were to take something like these two matrices, let's pick the 3 by 2 matrix again. And this time we're going to multiply it by the matrix that looks like this. That means this time we've got a 3 by 2 matrix and we're multiplying it by a 2 by 4 matrix. It's a 2 by 4 matrix because it's got 2 rows and it's got 4 columns. So, when deciding is it possible to multiply the two matrices together, the answer is yes. Yes, it is, because this number and this number are the same as each other. Okay, so that's how dimensions can be used to decide if it's possible to multiply two matrices together. But once you've decided that, the dimensions of the two matrices are also then useful for helping you know how big the answer to that multiplication is going to be. Or rather, I should say what the dimensions of the answer is going to be. So, let's look at that example again. We said we had the matrix 1, 2, 3, 4, 5, 6, which was a 3 by 2 matrix, and we had the matrix that was 7, 8, 9, 10, and then 11, 12, 13, 14. Very imaginative, I know. Okay, well, when we're multiplying two matrices together, what we're doing, as we've already said, is we're taking all the rows in the first matrix and we're multiplying them by every column in the second matrix. Now, the thing is, if we're doing that for every single row and every single column in both matrices, then that's also going to tell us how many dimensions there are going to be in the answer. The answer will have 3 rows because the first matrix had a total of 3 rows, so that's 3 different rows to be multiplying with. And the second matrix has 4 columns. And so if we're using each of those columns in the multiplication, our answer will also have that many columns. So basically, when looking at the dimensions of the two matrices, the middle ones decide if it's possible to multiply the matrices together, and the outside numbers of these 4 numbers is what decides what the dimensions of the answer to the multiplication is going to be. Okay, so just to demonstrate that, if we were to multiply these two matrices together, I'm going to skip all the work, I'm just going to give you the answer. The answer would end up being this. So that is the answer that we're going to get if we were to multiply those two matrices together. And as you can see, it ended up the size we expected because it has indeed got 3 rows and it's got a total of 4 columns. So numbers of rows, numbers of columns do end up matching with what we expected. Okay, there you go. That's how dimensions are important in deciding when it's possible to multiply matrices together, but also helping you decide what the size of the matrices is going to be once we've actually done the multiplication. Okay, thank you and goodbye.